Hi, my name's Jeff Dean, and I'm Math Dad. I'm here to help you help your kids understand math. Have you ever tried to help your kids understand a math concept that to you seems so simple? You've known how to do it for the longest time, and no matter how many times you try to explain to them how to do it, they just can't. Well, sometimes the reason why they can't get it the way that you're trying to explain it is because of something that some people refer to as the curse of knowledge. What the curse of knowledge is when we as adults forget what it's like not to know something, or when we forget what it was like when we had to learn it for the first time. I've recently been teaching one of my daughters how to drive. And one of the things that I struggle with is helping her become natural when it comes to accelerating or braking, or helping her understand how not to get the car to swerve when you're looking over your shoulder. You see, I can't remember what it was like to learn how to drive. To me, it's so natural that it feels like something I've always known how to do. So it's really difficult sometimes to break the steps of what to do down into pieces that she can understand and then use and put into practice so that she becomes as natural as I feel that I am. Well, this happens all the time in math. And I want to show you what I'm talking about using some division problems. So let's head on over to the white book to figure out what this looks like. So I'd like to use this division problem to help us take a look at how we might remember doing division, but how we can figure out how our kids might think about division and how to progress them along so that they can eventually get to what you and I probably say is how we've always known how to do division. When we look at a division problem like this, what we typically ask, or at least how I learned it, was, I have 16. How many times does 16 go into 1? 0 times. How about 10? 0 times. How about 102? And that's when the challenge came. How many times does 16 go into 102? See, if I had a single digit number here, I'd probably have a math fact that would help me. But I am not too good at my 16s. So I remember going on the search where 16 times 4 is 64. So it's got to be bigger than that. So let me try 16 times 7, which is 112. That's too big. Therefore, it has to be 16 times 6. So 16 times 6 is 6 times 6 is 36. 6 times 1 is 6 plus the 3 that I carried gives me 9. And then we subtract. And let's see here, I get 6 and that is a 9. So bring down my 7. And then we repeat the process. How many times does 16 go into 67? And I already have this over here, so I know it's going to be 4 times. 4 times 16 is 64. And then I'm going to subtract. I get 3, bring down my 2. And hopefully I know that 16 times 2 is 32. And I subtract, and I get 0. Now, this is the standard algorithm for solving long division problems. But where I find people struggle is when you say, how many times does 16 go in? How many times does 16 go in? And if they don't have a strong sense of math facts or really know what it means for something to go into something, they may struggle thinking about it this way. But let me show you, if we take a step back into another process that someone might go through to solve this problem, it might help us with our curse of knowledge. Because here's another way people might think about this. 16, how many times does 16 go into 10,272? I might not know the answer. But suppose I do know that 16 times 2 is 32. And I know what multiplying by 10 does. In other words, I know 16 times 20 then has to be 320. And 16 times 200 would then have to be 3,200. I might say, I don't know how many times 16 goes into this number, but I do know for a fact that there's at least 200 of them in there, and I can take out all 200 of those 16s. So I've taken out 200 so far. 2, 7, 0, 7. And I might say, well, 3,200 is still less than 7,072, so I can take out another 200. And I subtract 2, 7, 8, 3. And I might say, I have another 3,200 in here. And I have 2, 7, 6. Well, I can't take 200 of them out anymore, but I can take 20. 320. And then I can take another 20 out. And finally, I can take 2 more 16s out. And I get 0. So how many 16s did I take out altogether? In other words, how many 16s went into that number? 2, 4, 600, and 20, 40, 2. This is another way that people might think about division. See, if your student is having a hard time doing the standard algorithm, perhaps we're trying to get them to solve too big of a problem right away. Maybe what we need to do is rely on taking out pieces at a time so they can use facts that they may already know to help them break down a big number like 10,272. Let's take it back a little bit more. Let's start with a smaller number. Suppose we wanted to know 102 divided by 16. Well, my first question with someone, if they're struggling with division, is do they actually know what division means? So you see, division has two meanings. One meaning can be if I have 16 little boxes or circles or containers, and I need to put 102 things into those, how many will be in each container? That's meaning number one. So I have 16 places to put them, and I put 102 things into those containers. Let's see what we get. 1, 2, 3, 4, 5, 24. It's a great exercise in counting. 25, 26, 27. 58, 59, 60. Hopefully by this time they're thinking, oh my gosh, this is not the quickest way. But if this is how they think about it, this is how they think about it. 61, 62, 63, 64, 65, 66, 67. 100, 101, 102. Now, I wasn't able to fill in all the circles, so let me back out a little bit. I had 1, 2, 3, 4, 5, 6 that I couldn't use. So, the question is, how many are in each container? Well, I have 6 in each container, and I have 6 left over. So I didn't quite have a full 16, and that's where a remainder would come from. And just so you know, that's why we would say 6 out of 16 left. In other words, 6 and 6/16. But that's a lesson for another day. That is one way that some students think about division. So when you're working with your student and you ask them to divide, even if it's a really big number, and they start drawing circles and want to put tally marks in it, you need to understand this is where their understanding level is. So our goal is to start to say, well, instead of putting 1 in each circle, could we start by putting 2 in each circle? Can they count by 2s? Can we try putting 4 in each circle so they count by 4s? We try to get them to move one level of efficiency up. Because if they can put 4 in each circle, then they're going to get through those numbers quicker. And eventually, hopefully, they'll be able to see, oh, I could have just put 6 in each circle to begin with. So what is the second way to think about division? This is the second way. I have 102 things. How many groups of 16 can I make? So I have, there's 10, 11, 12, 13, 14, 15, 16. There's one group of 16. There's a group of 16. Here's a group of 16. Here's a group of 16. Here is a group of 16. 1, 2, 3, 4, 5, 6, 7, 8. There's a group of 16. I have 1, 2, 3, 4, 5, 6 groups of 16 and 6 left over. So again, I got 6 with a remainder of 6. Now you might be thinking, wow, that was a lot faster. Just keep in mind, I had already drawn out 102 circles. These are two ways that students may think about division. But if this is how they understand division, teaching them the standard algorithm is going to be tricky. So how can we do a problem like this? Well, if we have 16 into 102, we would like them to use the standard algorithm, but what's something that we've learned now that we could use? We could say something like, well, I know I can take 1 16 out. This would be like making groups of 16. And I would get 86 left. And hopefully the student would then say, well, this is going to take forever if I take 16 out at a time, 16 and 16, 16. So maybe I'll take 4 16s out. And 16 times 4, which we've already said was 64. And now there's 22. And they can say, oh, I can still take 1 16 out. And I get 6. And again, how many 16s did we take out? 6 of them, remainder 6. And once you get to this point, where they can see that they can take out different groups of 16, you can start to put the groups together. Can you see how you could have taken out 5? Perhaps we could have taken out 6. Could we have figured out how many we could have taken out at the beginning by just doing a little math over here at the side to begin with? Now you're moving them towards the standard algorithm, which is what we remember. But it's so important to remember that a new learner to division is thinking of this. They might be thinking about this. They might be thinking about drawing tally marks. Okay, it is possible that they're at this level already. There's so many stages in learning division. And if we suffer from the curse of knowledge, we're going to have a hard time showing them these things unless we take the time as the adults, the parents, the teachers, to learn these methods on our own and remember what it's like to learn. We might actually find another way of thinking about division that makes a lot of sense. Help those students defeat the curse of knowledge. My name's Jeff Dean, and I'm Math Dad. Thanks for watching, everybody. Again, thank you to my friends from Wipebook for these awesome flip chart white books. Makes doing math so easy because I can write, I can erase, whatever I need to do, and then take a picture and save it for later use. Thanks a lot. See you next time.